Queue na example of data structure wey be say the data wey dey inside am dey always dey in front of each other. You fit imagine queue to be a container wey be say the data wey dey inside that container dey always dey in front of each other. Before this time, we been discuss about the concept of array wey be say array na a type of container wey be say the data wey dey inside am dey always dey side by side by side. And also we been don already explain the concept of stack wey be say I talk say the data wey dey always dey inside stack dey always dey on top of each other. Right now, the concept of queue be say the data wey dey inside that particular container dey always dey in front of each other. I hope say you connect well with this explanation now. If you never still connect well with this explanation, no just worry yourself too much, because say I go still give you a real life scenario of wetin queue be. Wetin I go just do now be say I go just clear off this diagram of array and stack, make we come continue with our queue. A good example of wetin queue be na people wey queue to purchase or buy a bus ticket. Say we get people on top of this line now and they wan buy bus tickets. You sef you go don already dey hear the concept of queue behind yourself. So this term wey dem dey talk say queue behind yourself na computer term wey be say dem dey use dey represent information wey dey in front of each other. So this diagram wey you dey see here so like this, na wetin queue just be that. Say queue na example of data structure wey be say the data wey dey inside am dey always dey in front of each other. Right? Make I just first put partition here so that you go know say this data dey in front of each other. But as simple as this diagram wey I draw out so like this look, e get some other concepts wey be say we dey take note say na queue we dey deal with for inside computer. And this concept na wetin dem dey call FIFO. So FIFO mean say na first in, first out. That one mean say on this bus ticket buying queue, na the first person wey enter inside this queue na im go be the first person to comot for this queue after the person don buy im ticket. First in, first out. And you sef you go agree with me say anytime wey be say we wan form any queue, maybe to buy a bus ticket or to buy a movie ticket or to just do anything, anytime wey we wan form any queue, the queue dey always get entry point and e dey always get exit point. So anybody wey wan enter inside the queue, e gats get a place, a point wey be say the person must enter the queue from. And after the person don do whatever the queue is set up for, the person go also get a point to comot for the queue. So as we wan come implement our own queue, we gats factor in this concept of entry point and exit point. So these 2 points, we fit call this entry point to be rear or back. E no really matter the name wey you call your own. Just know say for inside queue, anytime we wan implement our queue, we gats get entry point and exit point. And for inside this explanation, I dey call my own entry point to be rear and my exit point to be front. So rear mean say na the place or na the point wey be say people dey enter inside our queue from. And front na the place or the point where people dey comot for inside this queue. Right. Before this time, I been don already explain say the beauty of data structure be say we dey perform different operations on them. Now, queue as a data structure no go make complete sense if we no dey perform any operations on am. So operations na wetin dem dey call methods. So methods or operation na different type of things wey we fit do inside our queue. So at this point, you sef you go not begin dey ask yourself say which kind operation we fit come do on top our queue, on top people wey dey on queue wey wan buy bus ticket. Well, the first type of operation or method, right, na enqueue. So enqueue na the addition of data inside our queue. So anytime wey be say new person come enter inside this queue, this ready-made queue wey dey here, wetin that operation be na enqueue. So enqueue na the addition of new data inside queue. Another type of operation wey we fit perform na show operation. So show operation go print or tell us all the elements wey dey inside the queue. Say for example, the data wey dey inside this queue no be human being again, na number. Say we come get 2, we get 8, we get 10, we get 7, we get 0, and we get 4. Right? So if we perform this show operation, e go tell us all of these numbers. E go print them out for us to see. All these numbers. Shey you get? Another type of operation wey we fit perform for inside our queue na dequeue. Now, this thing come begin dey make sense because say we dey add elements into our queue from this point wey be say we call rear, and anytime wey be say the person come buy the bus ticket finish, that one mean say the person dey comot for the queue. So as the person dey comot for that queue, the operation wey the person dey do na dequeue. So this operation mean say na deletion operation. Say the person we dey delete am comot for the queue. So if we dey add elements or data or person from this rear point, then we dey delete elements from this front point. That one mean say na the first person wey we add inside our queue, na im go be the first person wey go come out inside our queue. First in, first out. Simple, straightforward, and easy. At the end of this tutorial, when we come perform all these things wey we don use biro and paper take write out and draw out, so you sef you fit implement your own preferred type of operation or method inside your queue, depending on whatever thing wey you wan use your queue to do. I hope say you understand the concept of queue and the different types of method or operations wey you fit perform on queue, and also the concept of FIFO for inside queue. Wetin we go do next be say we go just come programmatically implement all these things wey we don draw out so for inside our IDE. So to come implement queue now, guys, I go just come inside this work directory folder wey dey here. Then I go just expand this folder. Then inside this SRC folder here, so I go just right click on the SRC folder, come create a package. Then I go just call this package queue. I go just call am YouTube queue. Right? Then I go just hit finish here. So inside this folder, as you see, I'm so like this, I go just right click. So before I continue from this point, I would like to say the implementation of queue go require us to create two different files, or you fit imagine the files to be classes. So the first file or the first class go be the one wey we go take implement our queue. Then the second one go be the one wey we go take run the implementation of that queue. So one na the implementation, the other one na the runner file. Shey you get? So I go just come here like this. First create the one wey we go take use the implement our queue. So I go just choose class here, so like this. Then I go just call am queue. I go call am YouTube queue implementation. Right? Then I go just hit finish here. So the next one wey I go do now, say I go just come inside this YouTube queue again, right click, come select class again. Then I go call this one YouTube queue runner. So this YouTube queue runner, as you dey see am so like this, I no go hit finish directly. I go come here, come check this public static void main option wey dey here. So this public static void main option wey I just check so like this, na im go be the engine wey go make am possible for us to fit run the first file wey we create. Shey you get? So now I go just hit this finish. So wetin we go just do now be say we go just begin the implementation of our queue inside this YouTube queue implementation. So before I continue, I explain say the concept of queue in computer science is the same in the reality of when, for example, you wan buy a movie ticket or bus ticket. So to buy movie ticket or bus ticket, everybody gats queue behind each other, and na the first person wey dey for the queue go be the first person wey go buy the ticket. and the queue go come begin dey continue like that until they come finish selling the ticket or the queue come finish. Now, anybody wey wan join the queue gats go join the queue from the back. So this thing wey I just explain so like this na refresher of everything wey we don conceptually draw out before this time. The first thing wey we go need do na to create the container wey our data go dey inside. So I go just come here like this, talk say int wetin be the name wey I go call this container? I go just call am queue container, because say na container itself. Queue container, then I go put this my angle bracket, then is equal to new int. Now, as I talk say is equal to new int, so like this, I gats be able to tell computer the capacity of this container, right? Then I go just talk say the capacity of this container go be 10. Shey you get? Then I go come to the end of this program, come end am. So this line of code wey I write so like this, right? Na the container wey be say we go come begin dey add data inside am. Shey you get? And the capacity of the container na 10. Shey you get? Then before we continue, I wan explain again say we go need 3 other variables. Remember the concept of queue, say e go get front, e go get back, and say e gats also get total size. So to take come implement that one now, I go just come here. Before I continue, I go just try zoom this thing so that you go fit see am well well. Right. So now to come take implement all these 3 variables wey I been don discuss now, I go just come here talk say in front, right? Then I go just initialize this front to be equal to 0, because okay, obviously the queue just dey start. Nobody don dey inside the queue, or nobody don comot for the queue. So the front now is 0. Shey you get? Then I go initialize the real variable also to be 0, equal to 0. Right. Then the total size, then I go initialize that one self to be int size to be equal to 0. Right. I no go like make you confuse this size with this 10 wey I been put here. So this 10 wey dey inside this line 5 code so like this, that one mean say this container fit contain total of 10 elements, right? So the size go come keep track of how many elements don dey inside this container. I hope say you get the difference. So now make we come quickly implement the enqueue method to take begin dey add data inside the container, right? So to come implement the enqueue method now, I go just come here talk say public void enqueue, right? And because say anytime we wan enqueue something, enqueue just mean say we wan add data inside that container. So we gats be able to hold that data wey we wan add to come put am inside that container. That one mean say inside this enqueue method, we gats put int data here. So this data wey I put here so like this, e fit be anything, honestly speaking. So this data, e no compulsory say you sef go call your own data. Shey you get? Na just name of anything, na just name of a variable. So then I go come here, come open and close this my curly parenthesis. Now inside this curly parenthesis now, na where we go come write the logic wey go make this our enqueue take work. So tey anytime wey we come perform this enqueue operation, everything wey dey inside this curly braces go come execute, right? So the concept be say we wan add data inside a container, right? That one mean say we gats get a way to take hold that container, come begin dey add that data inside am, right? So we gats call the name of that container itself. And you go remember say for this line 5 code wey dey here, we call the name of the container to be queue container, right? So I go just come here again talk say queue container. Then I go talk say okay, queue container now before I continue, I go wan tell you say, remember the concept wey I tell you say anybody wey wan join queue, the person gats go join the queue from behind, right? So we go use the concept of this behind, right? Take tell the person say if you wan join this queue, go start from behind. So now I wan instruct my computer say anytime we perform this enqueue operation, go inside this queue at index of real, right? So I go just come here put real here, right? When real be 0, right, you go just go inside the container at real 0, come add this data wey dey come from this our enqueue. So I go just come here talk say equal to data, Then I go close my program here, right? So as I don't add this data into this container at this particular index, right, I gats be able to increase this rear. So tey anybody wey wan join the queue again no go join the queue at index 0. The person gats be able to join the queue at the next index wey be index 1. So anytime I perform enqueue again, the person also no go start at the next person no go start at index 1 again, the next person go start at index 2, and e go continue to dey increase like that. So that one mean say I gats increment the value of our rear to allow space for the next person wey wan join the queue, or to allow space for the next data wey we wan introduce or add inside our queue, right? So I go just talk say rear is equal to rear plus 1, right? Then I go end my program here. Now as I don increment the value of rear now, so I gats also increment the size of our container, shey you get? So tey e go come dey keep track of this size as against the capacity of our container, shey you get? Then I go just come here talk say size equal to size plus 1, shey you get? So as this one dey like this, we don already implement the addition operation of queue wey be enqueue, right? So the next thing wey I go quickly talk about before we go run our program for inside this file be say we gats also get a way to show all the elements wey dey inside our queue, right? So now I go just come here talk say make we come create or implement the show operation. So I go just come here talk say public void show, right? So I go just come here talk say open and close this my curly parenthesis. Then I go come implement the logic wey be say when we perform this show operation, the things wey dey inside this show operation wey dey inside this curly parenthesis go come execute. And this thing wey dey inside this curly parenthesis na to show all the elements wey dey inside this container, right? So the way wey we go take do that one be say we go just use the concept of for loop, right? So I go just talk say for then int I equal to is 0, then I go talk say I less than size, right? Then I go talk say I plus plus. So if you no understand how loop take dey work, I dey encourage you say make you quickly check out for inside my YouTube channel. I bin explain the real concept, the logic wey dey behind how loop take dey work. So now as I use this for loop to take travel through elements wey dey inside that queue container, right? I wan come dey print out all the elements wey dey inside that queue. So to take print out all the elements now, I go just talk say system dot out dot print. And now because say the element wey we wan print out e dey inside this queue container, right? So we gats be able to tell our computer say go inside this queue container wey dey here, then print out all the elements wey dey inside. So I go just come here talk say queue container, right, of queue container of I, because say na the I variable wey dey here wey be the index wey we dey use dey travel through this container be that. So now I go just come concatenate our this line of code with space. So I go just talk say I go add one space here. So tey when this program wan come print out, you go come add space between all the elements wey dey inside this container, right? So we don implement our enqueue method and our show method. So wetin we go just do next be say we go just come inside this runner class, come take create the object of this class, object of this YouTube implementation class, right, inside this YouTube runner class, shey you get? If you still no understand the concept of object, I go encourage you say make you check out my video wey I don already explain the concept of object and how object take dey work for inside object oriented programming. So we go just continue from here. So to take come create the object of this YouTube implementation class, wetin I go do be say I go just talk say YouTube, the name of this file, YouTube queue implementation, then the name of the object itself. So I go just talk say my queue, I go just call this one my queue. So this name my queue fit be anything whatsoever is equal to new YouTube, or I will just come here, copy this one, Control C, come paste am here. Then I go close the program here. Then I will just end this program here, so like this. Make I just reduce this thing a little bit. Right. So why we dey create this object be say we wan get access to everything wey dey inside this class or inside this file, right? So now as we create this object wey be my queue, right, this my queue e don already contain everything wey dey inside this class from here to this place, everything, right? So now wetin we wan do be say we wan come begin dey add data inside that queue, and I already explain say this queue wey dey here don already contain everything wey dey inside this file, and importantly e don contain this container, right? So wetin we go just do be say we go just talk say my queue dot, if I talk say my queue dot now, you go see say e don bring up all the methods wey we don create. E bring up this our enqueue, right? And e come bring up this show method. Shey you get? So I go just talk say enqueue. So as I talk say enqueue now, you see say e highlight this place, right? E dey wait for us to type the number wey we wan add inside that container. So for the purpose of this tutorial, I go just put 20 here. So now if I run this program, you go see say nothing show for inside our terminal. Make I just bring this terminal up. You see say nothing show for inside this terminal wey dey here, right? The reason why nothing dey show be say we never perform our show operation, right? But we no get any error for inside this our program. That one mean say our enqueue method wey we write e dey work. So wetin I go do next be say I go just come here talk say my queue dot show. As I talk say my queue dot show now, you see say this one no complain say make we put anything inside am, right? Na because say we no tell am say e go contain anything inside am here. This one we instruct am say e go contain data inside am. Shey you get? So if I come back to this my YouTube runner class now, come press this runner button wey dey here, you go see say we get 20. Shey you get? Why we dey get 20 be say we dey add 20 inside this container, right? Using this my queue object. So that 20 e come here, come dey save inside this container wey dey here. I know say this thing go dey one kind say this information dey enter each other, but I dey encourage you say if you no understand am, just watch this tutorial again for like 2-3 times and e go come begin dey make total sense to you. So I go just come back inside our YouTube inside this runner class now, come add another element. So I go just talk say my queue dot enqueue, then I go put 400 here, right? So I go just come run this program again. Now you go see say we get 20 and we get 400. And between these two, you see say we get space in between them, right? So that is coming from this line of code. So if I remove this line of code here like this, right, come back inside this my runner class, come run this program again, you go see say e no dey well formatted. E come bundle the two numbers together. So I go just come back inside this my file here, come press Ctrl Z so that our program go come dey well formatted. So now we don implement how we go take add data inside container and how we go take show data inside our container or inside our queue container. So the next thing wey I go like talk about na how to come take delete data from inside our container wey be the queue. So to implement the queue now, I go just come inside, okay, I dey inside our YouTube queue implementation class already. So I go just come here to say, to come implement the queue, I go just talk say public int the queue. I can't even spell the queue, Queue. Then I go talk say, because say we wan delete data from inside our container, right? So we no go tell am say e no go contain this int data, because say we wan comot data inside am, right? We no wan add data, right? So we no go put anything in here. So I go come to the end of this line of code, come put this my open and close curly parenthesis, you go see say this one come begin dey throw error, say we say make we add return statement. The reason why e dey tell us say make we add return statement be say we don instruct our this line of code, this code wey we wan write, so we don instruct computer say e must return integer, right? You go see say this one we tell am say public void show. So void mean say e no go return anything, but this one we tell am say public int dequeue, so e must return a particular integer, and you go see am just in few seconds. So now I go just talk say okay, before I continue, make I quickly remind you say for on top queue, anybody wey dey on top of queue, if you wan comot for that queue, you gats comot for the queue from front, right? And na why we come get this front variable wey dey here. Here na for the people wey wan join the queue, the data wey we wan add inside the queue. So that one mean say if you wan dequeue, right, we gats dequeue the data wey dey inside our container from front, right? So now I go just talk say int data equal to queue equal to queue container equal to queue container of front, right? So immediately we perform this dequeue operation, right, we gats get a way to take increment our front. Shey you get? Then I go just come here talk say front is equal to front plus 1. Then I go end the program here. Front equal to front plus 1, right? And because say we dey remove from inside our queue, inside this queue container, right, then the size go also reduce. So we go just talk say size equal to size minus 1. Then I go end this program here. Now this thing still dey shout for us say error dey inside our code because of the return statement wey we never add. So I go just come here talk say return data. So this data wey we dey return na the data wey the number wey this program, this line of code, this queue container of front go give us. So I go just come here come end this my program here. Shey you see say everything don bam, right? So I go just now go inside my YouTube queue runner, right, come take dequeue the element. So I add 20, I add 400. Okay, make I just add 1 or 2 more. My queue dot enqueue, then I go add 50. I go do, make I just copy this code, Control C, come here, Control V, what is this? Then here I go add 90. Before I come perform the queue, I go just run this program again to ensure say everything still dey work. So we get 20, we get 40, 400, we get 50 and 90, right? So now I go just come here to say my queue dot dequeue. So now I go just come here come run my program. You see say this program don remove 1, but the issue wey we dey get now be say e go remove 90, right, instead of say make e remove 20. Now this place right now e fit dey a little bit confusing for you, say why e go remove 90 instead of 20, or why I dey talk say make e remove 20 instead of 90. So the concept be say this our code e dey work from top to bottom. So that one mean say this 20, right, na im be the first element wey go dey inside our queue. And if you interpret that one to reality, na the first person wey dey on top boss ticket buying queue, na im go be the first person wey go comot for the queue. So if this 20 na the first one wey dey inside our queue, right, based on say this program dey work from top to bottom, so follow by this 400, follow by this 50, follow by this 90. That one mean say na this 90 na im be the last element wey dey inside our queue. Shey you get? So if you wan perform the queue, e simply mean say na this 20 make e remove. Shey you get? So that one mean say even though say our code dey work, e come get a little bug inside am. Say e dey remove the last element instead of the first element wey enter the queue. I hope say you understand this explanation. So wetin we go just do be say the quick fix of this bug be say we go just come back inside this our program here, so like this, right? And inside our show method, right, we dey talk say go inside our container and print I for us. We no go print I directly, we go just talk say we wan print front of I, front plus I, right? So if I come back inside this my program here, so like this, right, come press this runner button, you go see say e dey remove the first element inside our container. So this 20 don comot, e come remain 450 and 90. So I go perform again another dequeue operation, my q dot dequeue. Then I go just end this program, come run this program again. Then you see say 400 sef don comot, e remain 50 and 90. Shey you get? So no be everything wey you fit do for inside queue be this o. There are a lot of things wey be say we fit still consider for inside this queue, and we go dey talk about all of these things later in the nearest future. But at this time, I hope say this information no dey too plenty for you to assimilate, e no dey too plenty for you to consume. So as e be say we don talk about the concept of queue, we don talk about the implementation of different methods for inside queue. Na so e go be for inside this tutorial. I go see you for the next tutorial.